What's up everybody, and welcome to a new video. And in this video we're going to go over my notes for the try except construct in Python, which is a form of handling errors. So here the first note is about a typical use case, namely you use it when the program relies on something from an external source. Namely, in that case you can't be 100% sure what response you will get from the external source. And examples could be user input, the existence of a file, or the availability of a network connection. So that is the typical use case for using this try except construct. And then here I also have an important guideline for when you use it. Namely, the exceptions should be as specific as possible. And they should be as specific as possible in terms of the errors that they catch. Because otherwise you might catch errors or exceptions that you didn't account for. And this in turn might cause bugs further down the line, which are hard to detect because the traceback doesn't go fully back to the try except statement. And to show what I mean by that, I've prepared here this image. So let's open that. So here, let's say that we have a file called program.py, which contains our code. And then here, somewhere down the line, we get here then an error. And then if you didn't follow here this guideline and didn't make this try except block here as specific as possible, then it might happen that you catch here an error that you didn't account for. And this will then, or can then be hard to detect because the traceback for this error only goes back here to this error and not here to this try except block. So this is why the exceptions should be as specific as possible. So now let's get to the different elements of this try except construct. The first one is the try block. Namely, this should ideally only contain the code that could cause the error. And that's because we want to adhere to this important guideline where we want to make the exceptions as specific as possible. So to demonstrate that, I've prepared here this function, which is called divide numbers. And here we get some user input, which we put into x and y. And then here we calculate x divided by y, put that into this variable called result, and then here print that out. So then let's also say that we somehow get some user input. And let's also say that we don't know what that input will be beforehand. So therefore then we want to know, we want to use here this try except construct. And then here I'm simply calling this divide numbers functions. So now let's use here this try block. And what you don't do is put both of these lines here into the try block. So what you don't do is say here try, and then put both of these lines into that block. And then after that, let's for now simply say here except and then print except. So this is what you shouldn't be doing, even though this works. And that's because we want to make our exceptions here as specific as possible. So this try block here should only contain the code that caused the error. So in our case, we are interested here in this divide numbers functions. So therefore this try block should only contain this line. So therefore then let's delete this line and let's put it in front of this try except block. So now if I paste it here, so this is now what this code should look like. And this is how you should use the try block. Then the next element is the except block. And this contains the code that runs if there is an error in the try block. In that case, then you take appropriate action. So for example, inform the user what to do instead. So for instance, in our example here, we could write that the input must be integers. So if I run it like this, then it prints out here that the input must be integers. So then here, the next note states that the except block should ideally be created for each specific type of error individually. And again, that's because we want to adhere to the point guideline where we want to make the exceptions as specific as possible. So for example, if I run here our divide numbers function, then you can see that we get here a type error. So then what we can say here is except we have a type error, then the input, then we print here that the input must be integers. So this happens then if we get a type error. So now let's see what happens when we get a different error. So therefore let's here delete here this 2. And now let's say that the input looks like this. And now if I run it like this, then we get here a value error. So therefore then in that case, we can create here another exception. So then here we say except we get here this value error. Then we want to print something else. So in that case, we could, for example, say there need to be 2 numbers. So if I run it like this, then it now prints here that there need to be 2 numbers. So this is what I mean by this note here, that the except block should ideally be created for each specific type of error individually. And here I also have a side note, and this states that multiple exceptions can be listed via a tuple. So to demonstrate that, let me just here copy and paste this code. And then here what we can do, instead of checking for just this type error, we can check for multiple errors. So for example, therefore then we put this here into a tuple. And then here we could add, for example, this value error. So if I do that and then run it, then you can see that this print statement here also gets executed, even though here we don't have a type error, but we have here this value error. And with this approach, however, we don't really adhere to this important guideline where we want to make the exceptions here as specific as possible. However, I nevertheless wanted to mention here this side note. Okay, so now that we've covered here this side note, let's get to this side note. And this is about the catch-all exception. Namely, sometimes you don't know what other errors might occur, and in that case then you can use a catch-all exception. So for example, in our code example here, we are considering a type error and a value error, and now let's create here a catch-all exception in case another type of error might occur. So therefore then we can simply here say except and then colon, and then here let's simply print some error occurred. So then let's also create an error that is not a type error or a value error. So therefore let's put in here a 0. And now if I run it like this, then you can see that it prints out here that some error occurred. So that's one way of implementing this catch-all exception, but there are also other ways. So for example, what you also can say is here except exception. And in that case, then here we can say some error occurred, colon, and then also print out that exception. So if I run it like this, then we get here this example, some error occurred, and then here this class. So it's the second way, and there's also a third way. So you can also say except exception as E, and then we can print out the E, and then the output looks like this, where it says some error occurred, division by 0. So that's how you can use a catch-all exception. And then when you use it, then you can use logging to document the errors. And then later on, you can then update the code, i.e. implement a more specific exception in order to adhere to this important guideline where we want to make the exceptions as specific as possible. So for example, in our example here, we can then create an exception for this 0 division or error. So we're going to say except 0 division. And in that case, then we can print, for example, that the second number can't be 0. So now if I run it like this, then it now says the second number can't be 0. Okay, so this is here my side note for this catch-all exception. And with that, now we've covered here all my notes with respect to this except block. Then the next element is the else block, and this is optional, and it gets executed after the try block was successful. So for example, let's here add an else block. So we're going to say else, and here we're simply going to print out else. And then here, when we have here the 0 division error, if I run it, then you can see that this else block here doesn't get executed. However, if I turn this 0 here into a 2, then you can see it prints out the 0.5, so the result, and then also here the else from this else block. So this is the second note here. And then the third one states that this else block contains the code that depends on the try block. And again, you don't want to put that code into the try block because we want to adhere to this important guideline. So to show that, let's say here in our divide numbers function, we don't want to print the result, but instead we want to return it. So we're going to say return result. And then here in this code, let's put this result here then into a variable. So let's say here result equals divide numbers. And then we're going to print the result here. So we're going to say result, print result, and then here in the else statement, let's say that we want to make use of this result variable. So for example, we could calculate the square of that. So therefore then here, let's say square equals result squared, and then let's also print out that square. So now if I run it like this, then you can see it prints out the 0.5, so the result, and it also prints out here the 0.25, which is here the square, which we've calculated here in this else block. Okay, so this is then how you can use here this else block. And then the last element is the finally block. And this is also optional, and this gets executed after the try and else block or after the except block, regardless of which one was executed. So to see that, let's create here a finally block. So let's say here finally, and then here for now, let's simply print finally. So currently we have here a 2. So therefore this try block is going to be executed. So now let's see what happens. And here, as you can see, it prints finally. So now let's make this 2 here again a 0. So therefore then we get here the 0 division error. So then if I run it like this, then you can see we get here a 0 division error, and finally also gets printed. Okay, so that is here the second note. And then the third one states that this finally block contains the code that depends on the try or except block. So for example, in our code example here, let's say that after we've done everything in here, we want to clear our user input. So we can do that here in this finally block. So here then we can simply say user input and then dot clear. And then let's also print out the user input to see if it has been cleared. So print user input. And now if I run it here with this 0 division error, then you can see we get here now this empty list. So it has worked. And now let's also see if it works when we use again our try block. So therefore here let's make this a 2. And now if I run this, then you can see we've again executed here the try block, and this user input is also again an empty list. Okay, so this is how you can use here this finally block. And with that, now we've covered all the available elements. And with that, then we've covered all my nodes with respect to this try except construct. And therefore then we've covered all my nodes with respect to error handling. So we've reached the end of this video. And then in the next video, we will go over my notes for the p.28 style guide. So thanks for watching, and hopefully I will see you in the next video.